Now what I want to do next is, instead of going into the subsystem and each time changing this value to, can we do something where all these variables are defined in a way that they can be changed from somewhere else? So let me explain you what exactly is the meaning of configuration of model parameters. So for example, right now these are the only two blocks which you have, and if I create another subsystem, right, so here you have another subsystem. So now when you go inside this, you have to go inside another subsystem and then double click on this and then change the value this 2 to your new experimental value. So instead of going into the depth of the model, let's say the level 1 and level 2 and then changing the value, why can't we create some variables where this value can be referred to, and that is going to make our task easy. So now we are going to discuss how to manage the model settings, right? So whatever are the model parameters, how we can actually manage them. So let me show you a simple block where the teeth ratio is 5, and basically we want to do an experiment where we continuously vary this value from one experiment to another experiment, right? So every time it is required to open up that model, and which may be inside a subsystem of another subsystem, right? So you have to go to that block and double click on that, and then only you will be able to vary it, right? So it may be tedious because this is going to be the case where you have the block parameters. Maybe you have many number of blocks available, and maybe instead of just one, you might have, let's say, 5 number of parameters to be assigned per block. And if you have 10 such blocks, probably you are going to assign 50 such values. So it's going to be really tedious in this case. Now when you are going to do the experiments, you have to remember all the values, all the parameters, and record the results. For example, in this case, let's say the gear ratio here is actually going to be varied from 5 to 10 to 15 and then finally 25 and maybe so on, so other larger values. If you are changing this gear ratio and analyzing the output values, which is output value 1, output value 2, and you are preparing a table or maybe a result table, then it's going to be difficult for you to every time do this exercise by writing here updated values. So what are the options? So how we can actually deal with this? So here there are many different options. So the first is we can actually connect the script data to the Simulink model. So for example, instead of 5, I can assign here gear underscore ratio, provided the gear underscore ratio is defined or is assigned variable in the workspace. So if we have a simple workspace variable which is equal to gear ratio, then we need not to go to the subsystem and write down the values manually, right? So let me actually do it with our block and help you to understand this. So now we are inside a simple gear and transmission file, and this is a model which we created, and there are 2 subsystem levels, and let's say here is the main file, right? Or here is a main block. Now we want to assign something to this gear ratio and something to this wheel radius. So let me write here wheel radius as radius. So I'm declaring this as radius, and let me use this simple gear. Now the moment I declare this as radius, it is going to give me some error, right? So what is that error? Basically it is giving me that unrecognized function or variables which are assigned inside the block, and there is an error. So before you hit the run, your MATLAB is so interactive that it will help you to identify any errors prior to you press the run button. Let's take care of this, where we have given this as radius and we need to declare the radius somewhere in the workspace. Now here the gear ratio, let's say this is GR. So now there are 2 parameters, one is GR and the radius assigned over here. Now let me go to the workspace. So how do you get the workspace? So workspace is somewhere over here, which is like this. And how to create workspace variable? So there are many different techniques of creating the workspace variable, and one simple is you create the variables like writing in the command window itself, where let's say gr is equal to, let's say, 8. So now we have created a workspace variable gr equals to 8 over here, right? Now let me create another variable by typing the radius equals to, let's say, 0.3. So now we have a radius variable also created in the workspace. Now let me check with my model, and probably now this models where the radius and the gr are declared, they are now not showing any more red, right? Because the MATLAB has taken all those variables from the workspace, right? So now if I run the simulation, I will be able to simulate my case with the previous values. Here we need to remember that because we were earlier running this in infinite mode, I need to press stop and understand what are the results. So with the given values of radius and the gear ratio, this is what we are getting in the output. For the fixed value of 360 input, we are getting somewhere near to 10 in the output. So probably this is the most simple way of creating the variables. Now let's say here we are dealing with the two variables only, right? So instead of two variables, and if we have a fairly complex system where we have around 50 variables, right? So it's always better to handle all this in a script file. So let's now learn how we can associate a script file to the model file, right? So let me create a new script. So here we have a new script. Let me save this as the parameter of the model which is related to gear, right? So gear parameter .m file I'm going to create here, and instead of typing all these parameters in the command line, let me clear all this. So here you can clear the workspace, and once you clear the workspace, all these variables will be deleted. So now instead of actually writing all these parameters in the command line, we can write down all those variables straightforward in the m file itself, right? So now let's say let me write a script where my radius equals to 0.9 meter and my gr value is equal to let's say 5, or let me keep it as 25. So now I have saved this file, and now let's go to our model and let's try to understand what is happening. So now I'm going to keep the simulation time which is fairly 10 seconds over here as highlighted, and let's see what is inside. So now again we are getting something unusual, and probably here you see the red color highlighted block. Now we have declared an m file, and probably the same variables we have assigned. I think I haven't made any mistake in typing as well. If you have a capital R or maybe some other spelling, then it's also not going to recognize. But I think radius is what we have declared in the m file. Okay, here you can see what we have declared over here. So what is the reason why we are not getting it, and what will happen if you click on run button? So let's go to the main diagram, and if we press the run, there will be some errors in the diagnostic viewer that the ratio and the other parameters are not declared, right? So this is what the error we are getting. Now the simple reason is your variables are not in the workspace, right? It is very important to understand how you can get the variables in the workspace. So probably we have type this M file, but we didn't click on the run, and therefore we do not have anything in the workspace, right? So if we click on the run, this script file is run, and now we have all the workspace parameters listed over here. And now I think with this we will be able to run our simulation. So let's try and run the simulation. Okay, now there are no errors, and we are getting the output results according to the values which are declared in the script file. So now with this, it's now clear that how we can use the script file to parameterize the model. And an important point to remember here is to save your script file and press the run button before you run your model. So it's very important to run script file first and then your model, because the variables which are available in the workspace, that will be only correlated with your model. Now, what are the things you need to keep record of? So remember, whatever we have files, let's say our gear transmission is a model file which we have created, and the parameter underscore gear.m is in the same folder, D drive new folder. So if your directory path is something different, then it is not going to work out. So now let's understand. Now we are going to see something else where we can use the Simulink block to create variables from the block itself, right? So instead of actually typing the script file, what we can do is, let's say we have a constant block like this, and this constant block is assigned some value 50 over here. Now instead of the 50 defined on this block, we can create a variable which is named as, let's say, engine RPM, right? So here we have the 3 dots, and if you click on this, you will be able to create new data, and that new data can be created either in the model workspace or the base workspace, and you can assign the name over here, right? So let's do it in the our model itself, and let's try to understand what will happen. So now what you see probably over here is with the Simscape blocks, this part is not available, right? So the Simscape block, probably you need to go with the scripting, and that is the better option. And for Simulink, it's possible to get it done by the values which are actually created in some variable way, right? If I double click on this constant, what we have here is the constant value 1 assigned over here, and if I press over here, which is highlighted part, then I can create a variable as well. So if I click on create variable, then I can give the name as let's say RPM, and the RPM is going to be saved in the model workspace, and we are creating this variable which is RPM, and which is now reflected over here and over here as well. So now we have created RPM, and instead of linking from the script or the workspace, it is now possible for you to link it from the block itself, right? So we have created something called RPM, and let's see what is happening in the model workspace. So if we refresh the model workspace, and if we run this part, or if we type this RPM, probably the RPM is not recognized, right? So here it's going to be the fundamental workspace or base workspace, and let me change it to the fundamental workspace. So here we have an RPM variable, and it is in the model workspace, and we can open this and we can change its value from over here, right? So you can change its value from here, or we can actually explore this in a model explorer. So what is a model explorer? Model explorer is basically going to open up all the values, and where you will be able to see the workspace which is related to the model. So here you have the model workspace which is related to the gear transmission file, and its value is 1 over here, as you can see, and you can modify from here. Now with this basic understanding of the model workspace, we can actually let's say delete this part and assign this as a constant 1, and now let's say try again with a create variable. So now I'm going to create a variable again with let's say revolution, right, and let it be defined as a engine revolution, and I can create in the base workspace. So we have created something called a revolution in the base workspace, and let's check it out over here. So here now in the base workspace, here we have something available as a revolution. So the important point to be noted down here is there are two workspaces for the model. One is the base workspace, which you can see from the command window, and another is the model workspace, which you can see from the model explorer. Now what is exactly the model explorer? You can take the help and type here the model explorer, and this will help you to understand how does the model explorer work. So here you can click on the model explorer view, and what are the meaning of all parameters, right, and how to utilize the model workspace part. So here is the important help where how to use the model workspace that is defined, and probably the model related data, and you can make it separate, right? What is the purpose of having two workspaces for the model? Basically, when you have something related to a complex model, when you would like to declare the variables which are related to models only, and you do not want your base workspace to be affected by this, right? And in that case, you can use the model workspace, otherwise you can use the base workspace as well. So here we have a revolution defined as a base workspace, and its value can be changed from here itself, right? So you can change the value 1 from here itself, right? And now if I type something called revolution, then the command line is going to understand what is the value, and the revolution 1 is available. So probably I can assign something in the command line itself, or maybe from here itself without actually opening up. So when you click on this and add the editing remark, you can change this value and probably let's say make it 10. So now the revolution value is 10. So now I hope you are able to connect the script data with the model parameters. And this is going to be very important exercise when you deal with many number of parameters and many number of models where you have such a complex model of a system.